Hey everyone, welcome back to the channel. Today we're going to be going over the second official GED topic in math geometry. If you haven't seen my other videos, you might consider checking those out first to know how to use that material. Otherwise, let's not waste any more time. Let's get right into it. But first I want to ask you, what is that thing? As a reminder, these are the topics we'll be going over today. You will be given formulas for most of these problems. If you are struggling with a certain topic, I will be providing references to Khan Academy videos that will give you a deeper dive into the individual topic. Those will be linked in the description. Number 1, side lengths of shapes given the area or perimeter. The shapes that they're referring to include triangles, rectangles, and polygons. Polygons is any shape that has straight edges and 3 or more sides. You may recall that perimeter is the length of the outside of a shape, while the area is the squared dimension of the interior of the shape. So for a rectangle, the area is 1/2 base times height, the base being the length of the side opposite the height. So we have the height here and the base here, and we'll do 1/2 base times height. The perimeter for a case like this will be adding up the edges a plus b plus c. Similarly, for a rectangle, the area is just the base times the height, and the perimeter is going to be all the edges added up. So b plus the same length over there, b plus h, or 2b plus 2h. An example question is this. A triangle has an area of 20 square inches and a height of 8 inches. What is the length of the base? So looking at our formulas, we can see that the area is equal to 1/2 base times the height. We will plug in the numbers. We know 20 square inches for the area. Pull down that 1/2. The base is what we are looking for, and the height is 8 inches. So then we'll just follow through all of our regular math. We'll multiply each side by 2 to get rid of this, and then divide by 8 to get rid of that, and equal with a base of 5 inches. Number 2, area and perimeter of 2D shape. And the two-dimensional shapes they're referring to include polygons and composite shapes. Polygons, you may remember, are any shape that includes triangles, rectangles, and more sides. Composite shapes will be any shape that combines 2 elements together. This is an example of a composite shape. We can see that it's made up of multiple rectangles along with half of a circle. The question asks, a pool is designed as shown. Yellow caution tape will be placed around the edges during construction. If the tape comes in 8-foot rolls, how many rolls are needed? So we can see we're given some dimensions here, but not all of the dimensions, and we're not given the radius of that circle. So first we'll need to figure out what the remaining dimensions are, and then since the caution tape will be going around the edges, we're actually looking for the perimeter here. So just looking at the problem, we see that there's a 10-foot section here and a 5-foot section here. Now we're assuming that all of these lines are perfectly straight, so the diameter of the circle here will also be 5 foot, and we know that the diameter is half of the radius. We'll learn that in the next section. So this is actually going to be 2.5 for that radius, and the other missing dimension is right here. And we can see that we have 8-foot section minus 3 right there, so 5 is what must be remaining. If you have questions about how I did that, ask them in the comments. So moving on here, we'll go around and add up the perimeter. So 5 plus 5 is 10, plus 3 is 13, plus 10 is 23, plus 8 is 31, plus the perimeter of half the perimeter of that circle. Technically, when we're talking about the perimeter of a circle, we call that the circumference. We'll learn in the next section that the circumference is equal to, I'm just going to move these down to 2 pi r, but we only have half of that circle, so we're going to do 1/2 2 pi r. R is the radius. We know that to be 2.5. It's looking a little messy here, but we'll follow it through. Add on the 31 from the 13, 23 plus 8, 31, and that's going to give us the perimeter. We end up with 4.36, and since we can't just purchase a third of a roll, we're going to round that up to 5 rolls needed, and that would be the answer. Like the first section, you're going to need to be able to work both ways if they give you certain dimensions of a circle to calculate the area and circumference, or given the area or circumference to calculate the radius or diameter. The radius of a circle is the length from the center point of the circle to the edge, and the diameter is twice the radius, so the full length from edge to edge of a circle. Diameter is 2r, or we can see that the radius is equal to d divided by 2, 1/2 the diameter. The area of a circle, the interior portion squared here, we will be given that as pi r squared. You may remember that pi is equal to 3.14. Perimeter of a circle is what we call that the circumference, but essentially the same thing. And the circumference is going to be 2 pi r. 3 quick problems to run through. The first one, if you're given the radius or diameter and you're asked to find the area or circumference. So let's say you're given a radius of 3 inches, you're just going to plug in chug. Remember, the circumference is equal to 2 pi r, 3 inches. You'll just plug that into your calculator and find it to be 18.85 inches. And the area, again, we're just plugging and chugging here. So we got pi r squared. Remember that 3 squared is just 3 times 3, and we'll find that to be 28.27 inches squared. Given the area, find the radius. So if you're given the area of a circle to be 25 inches square, we're gonna work backwards here. The area, 25 inches squared equals pi r squared. And then we'll just follow through basic math here. So r squared is equal to 25 divided by pi, and then we'll take the square root of each. So we end up with r is equal to the square root of 25 divided by pi. Plug that into your calculator. The last one, given the circumference, find the diameter. So we have circumference of 12 inches, and we see 12 is equal to 2 pi r. So we'll go through, figure out that r is equal to 12 divided by 2 pi. Remember, it's asking for the diameter, and the diameter is twice the radius. So the diameter is equal to 2 times 12 divided by 2 pi. And all you got to do is plug that in. Don't get freaked out by all this extra stuff in there. Plug it into your calculator, you're good to go. Number 4, use the Pythagorean theorem to find the side lengths of a right triangle. So first off, what is a right triangle? A right triangle is one that has a corner with a dimension of 90 degrees, meaning that or an angle of 90 degrees, meaning that angle is 2 sides completely perpendicular or opposite, you may think, of each other. So that's when we're able to apply the Pythagorean theorem, which says that if you have 3 sides of that triangle, the 2 sides that are next to that 90-degree angle are going to equal the other side when we square each one of them. So you may remember a squared plus b squared equals c squared. You're going to be given certain dimensions and asked to find the other dimensions, but only of a right triangle. Just as a reminder, the other types of triangles, we have an obtuse triangle when one of the angles is greater than 90 degrees, and then we also have acute triangles, which are when all the angles are less than 90 degrees. Remember, Pythagorean theorem only applies to right triangles. An example problem could look like this. You're given a triangle with the following dimensions. They may have angled it here some to try to throw you off, but remember that you're looking for that 90-degree angle, which is right there, and you're asked to find the dimension n. So here we will bring this formula down and plug in the numbers. Let's say that n squared plus 2 squared equals 3 squared. And we're using 3 there because it's the one that is opposite of the 90-degree angle. Then we'll come through and we know that that's going to be 9. We'd subtract 2 squared from each side, which is subtracting 4. N is equal to 5. That's the answer. Another sample problem that I accidentally wrote in blue this time. Let's say that you're told that a new phone is coming out and it has the following dimensions of 5.7 inches by 3 inches. And we know that screen sizes are measured on the diagonal from corner to corner. The question asks you, what is the screen size of this new phone? Applying the theorem, we can assume that each of these are right triangles and that the dimensions are the same on each side. So we're looking for the length opposite the 90-degree angle. And so we'll have 3 squared plus 5.7 squared equals that screen size, let's call it s squared. And we'll follow through just like we did up here to simplify and find that s, the screen size, is equal to 6.4 inches. Number 5, volume and surface area of 3D shape. Volume refers to the amount of space an object holds. So if we're looking at this fancy rock here, the volume would be the amount of space inside of it. The surface area would be all of the outside added up together. You'll be provided with the formulas for finding the surface area and volume of these shapes. You'll just need to know to recognize which dimension gets plugged in where. So for instance, if you're given a cylinder and they tell you what the height and radius is, they may ask you to find the surface area or volume. And the surface area for a cylinder is going to be 2 pi r h. 2 pi r squared. The volume for a cylinder is going to be pi r squared h. And again, you'll be given the radius and the height dimensions, and you can simply plug in and calculate the surface area or volume for any of these shapes. Just try to be familiar with how to apply those formulas to the given shapes. Similarly, you may be given the volume of a sphere and asked to find the radius, so we're working in the opposite direction here. But again, you're just going to plug in the numbers where needed and follow through with that calculation to find the radius. Number 6, graphical data. For these problems, you'll be provided any of tables, graphs, or plots and asked to interpret that and provide an answer. The interpretation, it's not going to ask for anything, real fancy, but it's going to be testing your knowledge of just being familiar with each one of these. I'm going to throw one up on the screen for each of them and give a quick explanation, but if you have a more detailed question, leave it in the comments. A table shows the raw data organized, usually the basis for other representations. A bar graph shows data using lines, usually with unordered data. A line graph is similar, but uses a line to connect the points, usually showing data that occur over time. A circle graph or pie chart shows how much each set is a percentage of the whole. Dot plots are basically bar graphs, except they have dots. Box plots show the range of sets of data. Histogram is a bar graph that basically could be a line graph, and scatter plots show all of the data points plotted often so you can see what kind of patterns emerge. Number 7, mean, median, mode, and range. When you're given a set of numbers like this, you may be asked to find the mean, median, mode, or range of that set of numbers. The mean, you may recall, is the average of that set of numbers. The median is the middlemost number. The mode is the most often occurring number. And the range is the largest number minus the smallest number. Let's use this data set to find each of these. So first I'm going to arrange this in order. So we have 1, 1, 1, 2, 4, 5, 6. Once I have that, the mean is going to be the average of all of the numbers. So I'll do 1 plus 1 plus 1 plus 2 plus 4 plus 5 plus 6. And then divide that by the total number, which there's 7 of them. And we will find out that just plug in those numbers, divide by 7, you'll have the average answer. The median is the middlemost number. We can see that here is going to be 2. The mode is the most often occurring number, which is 1. It occurs 3 times. And the range is going to be the biggest number minus the smallest number, so that would be 5. I didn't want to leave you in suspense, so the answer here, that average, turned out to be 2.9. You'll also need to find a missing value when given an average. So a question for that could look like this. After the test, Tom averaged the scores of his study group and found it to be 89%. The others in his studies group scored 88, 79, and 91. What did Tom score? So we're going to have 4 people apparently in this study group with the scores of 88 plus 79 plus 91 plus Tom's score, and then we divide that by 4, and we know that turns out to be 89%. So we'll multiply each side by 4 and then subtract 88, 79, 91 to end up with Tom's score to be 98%. He did really well on this exam, probably because he's a nerd and he's coming after the exam and averaging scores. So yeah, good job, Tom. Number 8, counting techniques. You'll need to count how many different ways objects can be ordered, arranged, combined, things like that. I get asked a lot specifically about the GED sample problem that is given, so first let's refer to that. I'm going to put it up on the screen, and it says, a restaurant serves custom-made omelets where guests select meat, cheese, vegetables to be added to the omelet. There are 6 vegetables available, and guests may select any 2 vegetables for their omelet. How many different combinations of 2 vegetables are available? So essentially, this problem is telling you that there's 6 vegetables. How many different combinations of 2 vegetables are possible? There is a formula that you can use for this, but the easiest way to depict this problem will be visually. So let's say that the 6 vegetables, we're just going to call them A, B, C, D, E, and F, and we can have 2 of them. One part that people get tripped up on is that the combination does not include 2 of the same vegetable. We're only looking for when the vegetables are different. So A and A vegetable would not be one that's valid. So we'd have A with B, A with C, A with D, A with E, and A with F. So we have 5 combinations so far. Now B with A, we already have that here. The order of these vegetables don't matter when they're thrown into the omelet. Which one was thrown first, which one was thrown second. It's essentially the same thing. So we already have B and A. B and B we're not using because we want different vegetables. So we have B, C, B with D, B with E, and B with F. So we have 4 combinations there. You may start to see a pattern here that C, we already have it with A, with B, not with C. So we have C, D, C, E, C, F, plus 3. And yes, you're right that you're just going to keep on adding until you get down there. So we have 5 plus 9, 5 plus 4 plus 3 plus 2 plus 1, 9, 12, 14, 15 possible combinations. The actual formula that you could use on this is that the combinations is n factorial, k factorial, and then n minus k factorial. Factorial refers, well, you'll see. So the n is the total number of options. So we'd have 6 options. And then the number of selections, that's what k is referring to, 6 minus 2 factorial. And then each of these, so 6 factorial means 6 times 5 times 4 times 3 times 2 times 1, divided by 2 factorial would be 2 times 1. And then 4 factorial would be 4 times 3 times 2 times 1. We can cancel out all these. So we have 30 divided by 2, or 15. Now you won't be provided this formula, but basically run through a problem like this visually is going to be probably the fastest way without getting into the nitty-gritty. Another example to build off the previous problem, say that you're the omelet maker, you're the chef, and you're placing the 6 different vegetables in the serving line. How many different ways can you arrange those vegetables? So you'll have 6 places. Let's say that you can actually place the vegetables. And so you have 6 places, 6 vegetables. How many different ways can you arrange the vegetables? So for the first one, well, you have 6 vegetables, so you can place any of them in that first slot. You come to the second slot, well, you've already placed 1, so you only have 5 available options, and we'll continue down until you're at the very last one, and you just have to place whatever you have left in that last spot. So then we'll come through, and the way we see how many different arrangements can be made is that we actually multiply all of these through to see what the number of arrangements possibly is. In other words, you may see that this is actually 6 factorial, and we plug that into the calculator, and you end up with 720 different ways you can arrange those 6 vegetables. Now let's say a question said that there's only 4 slots available for the 6 vegetables, then you would just do 6 times 5 times 4 times 3, because that's the number of possible combinations. You would not multiply by 2. So basically half of this 720 or 360. Number 9, probability of an event. Probability refers to the likelihood of something happening. In other words, the number of times a specific event occurs divided by the total number of possible events. Let's jump right into some examples. Oftentimes you'll see questions referring to decks of cards or dice for these types of problems because they're easy to use. The first question here, what is the probability of pulling a face card from a deck? So we know face cards referring to kings, queens, jacks, and the like. There are 12 total face cards in a deck of cards. Total deck of cards, there's 52. So we'd simply say the probability of pulling a face card from a deck is 12 out of 52. You could also simplify that to be 3 out of 13. You could also change that over into a percentage of 23%. Another question could ask, what is the probability of rolling 3 dice and getting all 5s? So we know that the probability of getting a 5 with a single dice is 1 out of 6. The fact that it's a 5 doesn't really matter. We just know that there's 6-sided dice and there's only one side that shows 5. So that would be 1 out of 6. To do it 3 times, we would simply multiply each time that we roll that dice and get the final answer of 1 over 216. We're changing that into a percentage. It's going to be something like 0.5% chance of that actually happening. Similarly, a question could ask, what is the probability of rolling 2 dice that sum to 6? So basically it's asking, what is the likelihood that you roll 2 individual dice and they add up to be 6? So of course, anytime that one of the dice rolls 6, the other one has to be more than that. So this is only going to occur a limited number of times, specifically when the first dice rolls a 3 and the second dice also rolls a 3. You could also have the first dice roll a 4, the second one roll a 2. The opposite is going to also be a unique event where the first one rolls a 2 and the second one rolls a 4. It's not the same. We're not going to combine the two where the same number shows up but on different dice. These are unique events, so each one occurs. We also have where 1 and 5 can be rolled on either one. So we have a total number of 5 times that it can happen. And if we're rolling 2 dice, we know that the total number of possible outcomes is just 6 times 6. So 5 out of 36, that's the probability of rolling 2 dice that sum to 6. We could also change that into a percentage if need be. So thank you for watching. Let me know if you have any questions in the comments. I'll be keeping an eye on those. Let me know if this video is helpful by throwing me a like. And finally, if you want to keep updated on my future videos as they come out, make sure you subscribe. After all that, check out these other videos.